Okay, in the bottom part of this sheet here, we're going to look at what are called even and odd functions. Even functions are anytime your degree is even, such as y equals positive x squared or y equals positive x to the fourth. We have positives here, and we know from parabolas, if you had a parabola that was a positive x squared, that would open up. Okay, and an x to the fourth is going to look similar to a parabola. It usually has some sort of wave in it, but it opens up on each side. Now, if the even function, again, even is the power here, if there was a negative in front of this, like y equals negative x squared and y equals negative x to the fourth, we know a parabola that opens, that's negative, opens down. So the same thing would happen on a fourth degree. This would open down, but it would sort of zigzag a little bit somehow. Not quite so dramatically, but it would have some sort of little wave in it. Okay? Odd functions, positive odd functions would be like y equals positive x to the third or y equals positive x to the fifth. And these functions look like this. And they might be a little bit more dramatic on the fifth power. Okay? And that would be positive. What happens is it starts off at some negative values here, and then it increases as you go from left to right. Negative would be like y equals negative x cubed and y equals negative x to the fifth. And those functions basically just flip these upside down, so they would go the other way. They'd go from a positive down to a negative. And then this is usually just a little bit more exaggerated. So even functions go up, up, or down, down. Odd functions go down, up, or up to down. Okay, and I normally remember the odd functions because of the 70s. In the 70s, the people that danced, their arms used to go up and down, and they used to dance like that. Either they danced like that or they danced like this, with their arms going up and down in opposite directions. Okay, so their arms kind of followed the path of the odd discos and people, and in the 70s everybody was odd. Okay, so let me go over a couple of the homework examples. Okay, so on your homework example here, in the first section, first thing they want you to do is use a graphing calculator to get the graph of each function. Then you're going to describe the end behavior, and the end behavior is going to be either up, up, down, 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 up, or up, down. Okay. And then you're also going to find any x and y intercepts. Okay. And if they're not whole numbers, you're going to go to the nearest 10. So on problem number 5, well, first let's do the end behavior. Let's do the end behavior on the first 3 here. Actually, let's go down. Number 5 here, since it's a negative even function, since it's even, it's up, up, or down, down. But since it's negative, we know this is going to be down, down. Okay. On number 8, since this is x to the 8th, and it is positive x to the 8th, we know that positive or even positive goes up, up. Okay. Skipping down to 14, if I skip down to 14, you'll see that this is positive x to the third, so that would be a disco function, so it's going to go from the negative up to the positive. If you move to the right, it's going up. Okay? So that's your end behavior. Now we want to find x-intercepts. So in order to do that, we're just going to use the graphing calculator. So on the graphing calculator, you're going to go to y equals. If your plot is on, we're going to make sure the plot's off. And then we're going to clear out the equation. We're going to type in our equation, negative x to the power. The caret key is the power of 4 plus x to the power of 3. So we're going to go ahead and hit graph. Okay, now my graph doesn't seem to match there, so we always make sure we zoom, and we're going to zoom 6, which is a standard graph. So we get our graph, and our end behavior does match what we were looking for, because we said on number 5 it should be down, down, and it is. Okay, now it's a little tough to see what's happening with the x-intercepts there, so we're going to try a new zoom. We're going to zoom box, which is option number 1. And zoom box allows you to put a box around the part of the graph that you want to see. So you always start at the upper left-hand corner of where your rectangle would want to be. Hit enter, and then as you move your right-hand arrow key, it'll start drawing the top of the box. And then if you move the down arrow, you'll get the box to open up. Now that you have a box, it's going to zoom in on that particular area. So hit enter, and now you can see. Looks like we have an x-intercept right here, and it looks like it goes above the x-axis and comes back down. So if I were to guess, it looks like I have an x-intercept at 0 and maybe at positive 1, because it looks like that's a little marking there for positive 1. So we can go to the table of values and check out the table of values, and on the table of values it looks like at x equals 0, y equals 0. And if y is equal to 0, if we think about on a graph, if y equals 0, then that would be right on the x-axis because you're not moving up or down at all. So here we do know that we have an x-intercept at 0.00, and then we thought the other one was at positive 1, and look at positive 1, that is a 0 for y as well. So that's an x-intercept and another x-intercept. Looking at the graph, looks like the y-intercept is at 0. And if you think about it, if you're on the y-axis, that means you're not moving left to right at all. So that means your x value would have to be 0, which coincidentally is this point. So point 0, 0, the origin is both the x and the y-intercept. Okay. So let's do a second one. I'm going to go right below. I'm going to do number 8 here. So on number 8, if I type in the equation, looks like I just need to get rid of this negative. So I'm going to get rid of the negative, change the power up to 8, and replace this with a 10x. Okay. And I'm going to go ahead and hit graph. Now I'm zoomed in from the previous question, so need to rezoom. So I'm going to zoom 6. Okay, now this graph does match what we expected. We expected it to be up, up, and it is up, up. But here it looks like this x-intercept is somewhere just a little bit smaller than -1, and this one looks like it's at 0. So let's check that out on the table of values, and we can see right here at -1, see how we go from -9 to positive 236. There's got to be a value of 0 right in between there, somewhere between -1 and -2. But we will notice that the origin is also a point, so that's got to be our x and y intercept. So that's one of our x's, and it's also our y-intercept. So now we're going to need to calculate out that other one. In order to calculate it out, we're going to do it on the graph. And we're going to use the calculate feature, which is right above the trace button on your calculator. So you hit second and the trace button. And then 0 here is actually the name for the x-intercept, and we're going to talk about that in tomorrow's lesson. So if you go to option 2, it's going to ask you a couple questions down here in the left-hand corner of the screen. First it says, go to the left-hand side. Well, I'm looking for this point right here. So what I want to do is I want to move my cursor until my cursor is on the left-hand side of that point. So I'm going to hit the left-hand arrow key, and the cursor is going to jump over to the left-hand side. Now it's all the way up there. So I'm going to hit enter. And then I need to bring my cursor back to the right, so I'm going to hit the right arrow key, and you see the cursor jumped all the way back to here. So now I'm on the right-hand side of this point, so I'm going to hit enter. That's going to ask me to make a guess. So the guess I'm going to make is going to be on the same point I just clicked on for the right. That always works, so I always use it. Hit enter, and it moves my cursor right to the x-intercept, which shows up at the bottom as -1.38. So that would be -1.4 if you went to the nearest tenth, comma 0. So that's your other x-intercept. Okay. So that's what you do if you need to calculate out your 0.